Hello everyone, hope you're all doing well, having a great time, staying at home and staying safe. So today we will start a new chapter. This is the beginning of a new chapter. We will try to talk about radioactivity. And of course this is class 9, chapter 14, section 1, part 1. So let's begin and good luck everyone. It is good to say that whenever scientists do experiment, they don't always find what they want to find or what they expect. So in 1896, a French scientist named Henri Becquerel found more than what he was expecting, or he actually found a new era in science. We will talk more about what he found in the next slide. So لسال 1896 زانەیەکی فەڕەنسی ناوی هنری بەکرڵ بوو زۆر لەوە زیاتری دۆزیەوە کە بە شوێنی ئاگەڕا. So he made a hypothesis based on that. His theory was that fluorescence minerals give off X-rays. Before we talk about this, that's his picture right in front of you, and basically what that is a fluorescent mineral. A fluorescent mineral glow when light shine on them. So the second picture is the same rock under the light, as you can see right there. Also, the other picture is his experiment, and in the second slide we will talk more about what he was experimenting on and what was his idea. So لێرە پێویستە تۆ بزانی کە بەکرڵ پێیوا بوو گریمانەی ئەوە بوو کە fluorescence mineral glow when light shine on them. So mineral fluorescence ئەدرەوشێتەوە ئەگەر ڕووناکی بکەوێتە سەر. Now to reach this idea he had to do an experiment. بۆ ئەوەی بگا بەم گریمانەیە he had to do an experiment. ئەبووی ئەکسپریمنتێ بکە بۆی بگاتە ئەو پۆینتێ و ئەو ڕاستی بۆ دەرکەوێت. لە سلایدیدا هەتووە باسی ئەکسپریمنتەکە یەکەین چی کرد و چی بەکارهێنا و ئەو شتانە ئاکەین. So what was Becquerel's hypothesis? It was that fluorescent minerals give off X-ray. So fluorescent minerals glow when light shine on them. Becquerel, to test this idea, he put a fluorescent mineral on a top of photographic plate. بۆی تستی ئایدیەکەی بکە بەکرڵ چی هێنا فلۆرسن مینەڕاڵەکەی هێنا منەر بەردێکی ئابوو لەو شێوەیە هێنای خستی سەر فلیمێکی فۆتۆگرافی باشە then کردێ بەردەمی خۆر. He put after putting it in a bright sunlight the film developed. So فیلمە فۆتۆگرافیەکەی وەکو لە ڕسمەکەی پێشووترا بینیت لە سلایدەکەی پێشووترا بینیت he actually saw a strong image of a mineral. تابلۆیەک لەسەر فیلمەکەی دروست بوو. So he tried to analyze his experiment. هەوڵێ کرد بزانێ ئەمەش لە چۆ هاتووە ئایا بەهۆی بەردەکەوەیە یان بەهۆی تیشکی خۆرەوەیە هۆکارەکەی چییە. Now there's another thing I should tell you that usually scientists when they do experiment they don't do it one time and leave it and okay we've reached the result and that's it. No, they try to use different techniques and see if they actually reach the same result or get the same result. So what Becquerel do, he tried to repeat his experiment, but the weather was cloudy. We see ئەم جارشیان ئەکسپریمنتەکەی دووبارە کاتەوە Becquerel بەڵام ئەمڕۆ ئەو ڕۆژی کە تیا کرد sorry ئەو ڕۆژی کە ویستی ئەکسپریمنتەکەی تیا دووبارە کاتەوە خۆری لێ نەبوو کلاودی بوو ینی ڕۆژێکی هەوری لێ بوو. So he tucked his experiment in a drawer. When he looked at the film later, he realized that the energy penetrated the paper and made an image on the photographic plate. کات ئەم جارە ویستی بێکڕۆڵ هەوڵیا تاقیکردنەوەکەی دووبارە کاتەوە بەڵام کەش و هەوا هەور بوو سو هەموو کەرەسەکانی کۆ کردەوە و کردێنە و چەکمەجەی کتێبخانەکەیەوە دوای پاش ماوەیەک ڕۆشتەوە سێری کرد سێرەکە وێنە فۆتۆگرافیەکە دەرکەوتووە لە سێری ئەم پێشتر بەکڕۆڵ وای بیریە کردەوە کە بەهۆی تیشکی خۆرەوە وێنەکە لەسەر پلیتەکە لەسەر فۆتۆگرافیک پلیتەکە دروست بووە بەڵام ئێستا تیشکی خۆری لێ نەبووە ئەم وێنەی لەشەوە هاتووە. After repeating his test several times, Becquerel concluded that this energy comes from uranium, the mineral, an element found in a mineral, not because of the sunlight. Okay, naming unexpected. So they knew that there is some kind of energy that makes the photo appears on the photographic plate, right? So they named this energy nuclear radiation. The energy is called nuclear radiation, and which is a high energy particles and rays that emitted by the nuclei of an atom. Oh, energy دوزیانەوە ناویاننا nuclear radiation. The high energy particles and rays are emitted by the nuclei of some atom. Kawata high energy particle yan rayin tishkin kalakyo derachin la nucleasi hanek atomo deracha yan gadila. By the way, the picture you're seeing right in front of you is the picture of Marie Curie. Mary was working with Becquerel. She named the process radioactivity, which is also called radioactive decay. What is radioactivity? Radioactivity is the process by which unstable nucleus give off nuclear radiation. So it is unstable nucleus and it gives off nuclear radiation. It is a process because of it or unstable nucleus nauki najigir tishki nauki dadaparanın release or emit nuclear radiation. Now as you can see we have a radioactive atom. It releases energy, radiation and particles also. In this lesson we will try to talk about radioactive decay. During radioactive decay, an unstable nucleus give off particles and energy. And we have three kinds or types of radioactive decay. The first one is alpha, and that's the sign of alpha. The second one is beta. Third one is gamma. So we have alpha decay, beta decay, and gamma decay. Talking about the first one, which is alpha decay. So alpha particles is made up of 2 protons and 2 neutrons. So their atomic mass is 4. But do you know which kind of charge the alpha particles carry or which kind of charge they have? I think you know that inside the nucleus we have proton, neutrons, and we have also electron that is around the nucleus. So we will talk about what is inside the nucleus, which is neutrons and protons, right? And you know that protons carry a positive charge and a neutron doesn't carry any charge. So if an alpha particles carry 2 protons and 2 neutrons, what do you think their charge should be? Exactly, it should be positive. So alpha particles carry a positive charge. It has a mass number. I already told you that it has a mass number of 4, and their charge is 2 positive. Let me ask you, what is a mass number? To answer this question, I'll ask you to go to the back of your book and to page 316. Look at the periodic table of the element. Look at the carbon. Yes, in the top of your book you can see carbon. There's a lot of illustration on the carbon element. You can see the atomic number, you can see chemical symbol, you can see element's name, and you can see atomic mass. Now what I want you to see is atomic mass. What is atomic mass? So atomic mass is the number of the numbers of the proton and neutron, while atomic number is the number of the protons only. So it is very, very important for you to know what is atomic mass and what is atomic number, and what is electron, what is neutron, what is proton, because you're going to need each and every one of them. Basically, a neutron and proton exist inside the nucleus, while electron is actually orbiting around the nucleus in every atom. So you'll have to know and differentiate each one of those. I'm gonna ask you a question, which is, what is a mass number? Mass number is the sum of number of the proton and neutron in the nucleus of atom. For example, the numbers of a proton in a carbon is 6, and in neutrons is 6. So the mass number, the atomic mass, should be 12, as you can see it in front of you. Now, for more illustration, I want you to go to the back of your book, to more specifically to page 316, 317, and look at the periodic table of the element. You will see the carbon as an example on the top of your book. So the first thing, we have atomic number, which is a 6. Then chemical symbol, which is a C. Element name, which is carbon. Atomic mass, which is 12. Now this part is what I am talking about. Obviously, this is 12.0, which is says 12. Where did this 12 come from? It is actually, it's the sum of the proton and the neutron. Now look at the helium. The helium has an atomic number of 2 and atomic mass of 4. I want you to look at the helium now, because we're gonna mention it later on. كواتا بارست جماريان atomic mass كوي جماري بروتون و نيوترونەکانی ناوکی گەردیلەیەکە. For example, کاربۆنمان لێرە نووسیوە. کاربۆن پرۆتۆنەکانی 6، نیوترۆنەکانی 6، کەواتە atomic massi چەنە؟ 12. Exactly. So atomic mass چییە؟ کۆی ژمارەی پرۆتۆنەکان و نیوترۆنەکانی ناوکی گەردیلەیەکە. It is important for you to know that هەموو گەردیلەیەک لە چی پێکاتوە؟ لە ناو نیوکلیسی هەیە، پرۆتۆنی نیوترۆنی تایە، لە دەریشەوە ئیلکترۆنی هەیە. ئیلکترۆنەکان ئۆربیتینەکەن بە چواردەوریانە. As you can see it in front of you, right there. We have an atom. The atom is composed of a nucleus. Inside the nucleus we have proton and neutron, and outside the nucleus we actually have electrons. The electrons carry a negative charge, while the protons carry a positive charge, and also we have neutrons. Neutrons doesn't carry any charge. Back to the alpha decay. So as you can see in the pictures in front of you, there is that's a radium atom. You can see what is inside the nucleus, proton and neutron. What is outside the nucleus, and how the electrons are orbiting around the nucleus. Now, I want you to know that many large radioactive nuclei give off alpha particles and are converted into a nuclei of an atom of a new element. So it becomes a new element. For example, as you can see in front of you, we have a nucleus of the radium 226. By the way, the number that follows the name of the element is the mass number of that element. So زۆرێک لە ناوکە تیشکدارە گەورەکان تەنۆرکی ئافا دەرەپەڕێنن و دەگۆڕێ بۆ ناوکی توخمی تازە. بۆ نمونە لە نمونەی رادیۆمە لە بەرچاوتای بینی رادیۆمی 226. ئەو 226 ژمارەی بارستە ژمارەی گەردیلەیە. کەواتە ئەو ژمارەی کە لە دوای ناوی توخمەکەوەیە بارستە ژمارەی قليلة. Okay, so it is actually mass number. Let's talk about what happened in this decay. What had happened to radium and how it becomes radon. The first thing you should know about the radioactive decay is mass number is conserved, so no mass is lost. The mass number is conserved. So the sum of the mass number of the starting material, in this example it is radium, is always equal to the sum of the mass number of the product. In this example, it is radon and helium, which is the alpha particle. So essentially, they are positively charged helium atom, stripped of their electron. Okay. بۆی بارستە ژماری مادە سەرەتاییەکان هەمیشە یەکسانە بارستە ژماری مادەی بەرهەماتوو. سۆ بارستە نابێ ون بێ، ونیش نابێ. ئەگەر سێری ماسنەمبەری ڕێدیەم بکەی ئەبینی 226. ئەی هینی پرۆدەکتەکەمان چییە؟ هیلیەم 4 و رادۆن 222. سۆ ئەگەر کۆیان بکەیتەوە ئەبێ یەکسان بن. ئەم سەر و ئەو سەری هاوکێشەکە یەکسانن. پرۆدەکت و starting materialەکەت یەکسانە. Okay, the second one is the charge is conserved. So the sum of the charge of the starting material is equal to the sum of the charge of the product. Look at the charge. The charge of a radium is 88 positive, right? In the other hand, we have, or in the product, we have radon 86 positive and a helium particle which has a charge of positive 2. And you can see that the charge is conserved because 88 is actually equal the sum of 86 and 2. ئەگەر سێری چارجەکانیان بکەی ئەتۆمیک نمبەری پرۆتۆنەکانی رادۆن تەنها چەنە؟ 88. ئەی لەو سەر لە پرۆدەکتا چیمان هەیە؟ هیلیۆممان هەیە ئەتۆمیک نمبەرەکەی 2 and رادۆنمان هەیە ئەتۆمیک نمبەرەکەی 86. ئەگەر 2 لەگەڵ 86ەکە کۆکەمەوە یەکسانە بەچی؟ 88. بۆیە بە هیچ شێوەیەک بارگە نافەوتێت هەروەها سۆ بارگەکان پارێزراون. سو دووشتمان هەیە لە کاتی ئەلفا دیکەیە. ئەو دووشتە چین؟ یەکەم شت پاراستنی بارستە ژمارە، دووەم شت پاراستنی بارگە. So the first thing, mass number is conserved. The second thing, charge is conserved. Since I want you to understand it very well, I found this image. It also talks about radium, how it actually, an alpha decay happens to it and it becomes radon 222, and it also releases alpha particle, and in this case a helium. So it loses 2 protons and 2 neutrons, as you can see. So atomic number decreases by 2 and mass number decreases by 4, as you can see it in front of you. So atomic number aquí اگر سير بكي لسرتها 88 دوای ابي بچی ابي به 86 و 2 particle اللي كما بيتو بلام اگر سيري mass number aquí بكي 226 ابي به 222 يعني چني لكم بوتو 4 لكم بوتو. Moving on to beta decay. What is beta decay? So basically a beta decay is the release of a beta particle from the nucleus is called beta decay. A beta particle can be an electron or positron. A positron is an electron with a positive electric charge or anti-electron. So once again, a beta particle can be electron or positron. What is a positron? It is basically an electron with a positive charge. But electron and positron have a mass of almost 0. Therefore, the mass of a beta particle is 0 because it has no proton or neutron. So the mass number of a beta particle is 0. كواتا درپرانی تنورکی بيتا لناوك بيدوتي بيتا شيبونوي بيتا اگونجد تنورکی بيتا الكترون بيان بوزيترون اگر الكترون كان negatively charged بن كواتا بوزيترون كان positively charged. اوكي هر كان بنزيكي يكسان بصفر كواتا بارست جماري تنورکی بيتا يكسان بصفر. So mass number of a beta particle is 0. Don't forget that. Let's talk about carbon decay. Carbon decays by the process called beta decay. During this process, an atom of carbon 14 decays into an atom of nitrogen 14, during which one of the neutrons in the carbon atom becomes a proton. This increases the number of the proton, obviously, as you can see it right in front of you. It increases the number by 1, creating a nitrogen atom rather than a carbon atom. So, during this kind of decay, a neutron breaks down into proton and electron. Notice that the nucleus becomes a nucleus of different element. It totally changed. And both mass number and charge are conserved. Let's start with the carbon and its mass number. Obviously, the mass number of carbon is 14, but also the mass number of nitrogen is also 14. Before I answer you, let me ask you a question. What is the mass number of a beta particle? It is the 0. As you can see, so nitrogen plus 0 is 14. So the mass number was conserved. What about the charge number? You can see that the carbon has a charge of 6, right? But the nitrogen has a charge of 7. But this can be solved. This problem can be solved. How? Since this kind of decay, the beta particle in this kind of decay is electron, and electron has a negative charge. So a 7 or a positive 7 plus negative 1 is actually 6. So the charge was also conserved. Moving on to the gamma ray. What is a gamma ray? Gamma ray is a pure energy. Also, it does not have mass or charge. Let me explain furthermore. You know that energy is given off during alpha decay and beta decay. Part of energy is in the form of invisible light, which means that you cannot see it. That has a very high energy. This energy is called gamma ray. So in the beta, when we explain beta, you can see the gamma ray as energy released in a beta decay. It could happen in an alpha decay too. The release of gamma rays from a nucleus called gamma decay. So whenever a nucleus releases gamma ray, it is a gamma decay. The decay, as I explained earlier, has no mass or charge. So gamma decay alone does not cause change in the kind of element. لكاتي شيبونوي الفا وبيتا وزا دردبرة بشكل وزا بشوي روناكي نبين راوة يعني invisible light. أم روناكي نبين راوة وزاكي برزو زوري هيا كلي درجات بيوتي تشكي جاما ودربراني تشكي جاما لناوكو بيدوتت شيبونوي جاما. أم شيبونوي نبارستيه ونا بارگشی هەیە و ناژبێتە هۆی گۆڕینی توخم بۆ توخمێکی جیاواز چۆن وەکو بێتا و ئەلفا ئەیانتوانی توخمێ بگۆڕن بۆ توخمێکی تر بەهۆی شیبوونەوە بۆ نمونە ئەلفا شیبوونەوەی ئەلفایان شیبوونەوەی بێتا. Okay, thank you for your attention. Of course, we finished the first part. I will see you in the next lesson and we will finish the second part. And I have so your homework, and good job for all those who done it. And those who didn't try with it, please try, because practice is actually what makes you learn more. So دەستان خۆش بە ئەو کەسانی کە هۆمۆرکەکانتان کردبوو، دەستان خۆش ببینیومە و ئەو کەسانیشی کە نەیان کردووە محاولەیان نەکردووە بیکەن، یا هەنێکیان کردو و هەنێکیان بەجێ هێشتووە، محاولی لەگەڵا بکەن لەبەروی actually جوابانەوەی ئەو پرسیارانە وا لێیەکە زیاتر تێبگەی یان پرسیارە لەلا دروست بێ. So good luck and I will see you in the next lesson.